Hey everyone, welcome to our last lesson with new content for Unit 4B. I want to give you an important reminder that at the end of next week, we will be having our first summative. Lessons next week will be live, and so you will be logging in at class time. If you cannot make it at class time, I expect an email explaining why you cannot be there. They are all focused on preparing for that first online summative. So we're taking a few days to make sure we understand the technology. As a reminder, those are the three topics that the summative is going to be on. So use that as a reference and begin reviewing for it. All right. Here's today's objective. Now, I always try to teach you multiple ways of approaching the same problem, so you can decide what you feel most comfortable, or some questions are better suited than others in certain methods. So we're going to learn an alternative way of solving word problems that result in proportions. Now, every question that we're doing today, we've done in the past. I'm just going to now solve them using a different approach. Now, the first thing is we are going to need to remember how to convert percentages into decimals efficiently. So I have a couple questions built into this PlayPosit for you to do just that. Make sure you read the feedback if you are having difficulties with it. All right, best of luck. So you'll see in a moment why it was really important to know how to turn percentages into decimals. Now, here's our first question, and we've done this question before, and real quick, I'm going to look at it with the old approach. So we were looking and we were saying, okay, X represents number of empty seats. And we knew that it was 72% out of the 100 equals the part that matches the percent empty. So here's the percent empty. And so we have the number empty, which is our X, over the total number of seats, which is 200. We were able to cross multiply to get 100X equals that. Divide by 100 and get 144 empty seats. Now, the trick we're going to use today is actually going back to one of our words, and that's of. And of often infers multiplication. So when we see the word of, we think multiplication. So if we're looking at this problem, it's saying 72% of the entire train is empty. Now, we're going to use some of our words. Well, 72%, we can write that as 0.72. Of is multiply. The entire train is 200. Is referred to as equal. Well, number of empty seats. So actually, let me go back over here and change that so we don't get confused. We'll use parentheses instead. Equals X, the number of empty seats. And when we perform 0.72 times 200, we get 144 equals X. So instead of setting up a proportion, we just set up an equation and we use the fact that all of a sudden of means multiply, is means equal. And we filled in the information where we needed it. All right, make sure you get this down in your notes so you have one of the examples. We're going to look at another one real quick. So I've written out the way that we did it previously. Again, note that I said percent not near the cities. That's why I wrote 21, because 79% were, 21% were not. That matches our number of not near. Now let's take a look at what we're doing. Now originally we had 79% of the population do. So therefore, we would say 21% of the population do not. Well, 21% is the same as writing 0.21. Well, we saw of, so that's our multiplying the population, 320, is the people who don't live there. And when you do that math, you get 67.2 equals X. So it's another approach of solving the same exact problem. So let's now generalize what's happening. Here's the key takeaway. The percentage written as a decimal, so that was our first, if we use the example we just used, 0.21 times the 320 equals the 67.2. So we're saying that the percentage, which was 21%, written as a decimal, multiplied by the original value is equal to the value compared to the original. Another way of saying this is this number is the value that matches the used percentage. So for the sake of this, play pause it, for us to all be on the same page, I am going to discuss it as A times B equals C. So if I ask you a question, which value is this? We're saying that A is going to represent our percentage, B is representing our original value, and C is our comparison value. All right. So using this, here's a practice problem. See if you can tell me what, oops, sorry about that, A, B, or C are when we use this relationship. Go ahead. So since we have a 5% increase, that is the same thing as saying 105% the original, which is 1.05. So see if you can now use that to find the answer. Go ahead. So here we are. We have 105% of the original, so that's why it's 1.05 of the original times 88 equals 92.4. So we can have 0.4 of a griffin, so we have 92 griffins. All right. Here's practice 2. Again, think about what value you want to plug in to both of these questions. All right, go ahead. So I did this one in 2 ways. Notice that I defined the one on the left as X amount to reduce. Well, that's 14%. So I said 0.14 times 36, and I got 5.04 million to reduce by. On the right, I said the amount to have left. Well, reducing by 14% means keeping 86%. That's this right over here. And that means I'm using 0.86 times 36, which gives us 30.96. Now the end question says, how many tourists are they hoping to have in 2020? Well, the way on the right has answered it, 30.96. The way on the left, I now have to say 36 minus 5.04, which gives me 30.96 million tourists. So I can still get to the answer. It just requires that extra step at the end versus the beginning when we change the percentages. So I have another example for us now. Now in every example, I have given you A and B and you found C. But that's not always the case. I have to give you two pieces of information. In this case, what we notice is we are missing the percentage. Well, that's A. So we're missing the A. We're saying, okay, what percentage increase occurred? Now, our starting value is 38, and where it went to was 45. Now, there's different ways of doing this one as well. So either we can say, A multiplied by 38 equals 45. And when we end up doing this, we divide by 38 and we get A equals 45 divided by 38, 1.18. Or the other way we could have done it is we could say, okay, A times 38 equals 7, where I'm only focusing on the increase. And when I divide by 38, I get A equals 0.18. Now, these are actually saying the same thing. This right here is saying an 18% increase. Well, this right here is also saying an 18% increase from the original 100%, because that 1 represents 100. So just make sure when you get your final answer that you're answering the correct question. You might have to modify what you have. All right. Here's practice 3. Give it a chance with this new method. So we ended up missing the A again. Now I did just the increase, so it's 302. So I divide by 148 and I get A equals 2.04. And this is a 204% increase. If you had done it the other way, you would have said A over 148 equals a 450. So this includes the 100% plus increase. So when you divide by 148, you would get A equals 3.04. Well, this is taking into account that 100%. That's why we subtract that 100% and still have a 204% increase. All right, let's go on to the next practice problem. Here you go. Give it a shot. So it becomes really easy when we're missing the final value, the comparison value. So 17% of the population live in Lombardia. So 0.17 times 61, using that word again, of, is our 10.37. All right. Hopefully we're trying to decide. Sometimes we like one approach versus the other. They're both very useful. Okay. Here's practice 5. Go ahead. So just for us to see on this last example, we have percent read matches pages read. And when we solve the equation, we got 0.63, which is the same as saying 63%. So I have a couple questions for you at the end of this play posit. And other than that, make sure that you take advantage of this weekend to do a little studying. So next week, you can ask questions as we have our live classes. See you guys next week. Bye.